And that's the motor hub that's making the whining. Yeah, look at that. I'm well happy with that. It hadn't been spinning very fast because it hadn't turned into the wind properly, but because of how I wanted the design to not have a tail, that's how it worked. But now it's turned into the wind, it's really going round, and because it is producing electricity, it's making that humming noise. So yeah, I'm going to do some testing on it. I don't know how much power exactly it's producing, but I'll find out. I'll put it up in the next video. Take it easy. Yo, what's up? Another video about what I plan to do with the turbine. I'm just going to show you. I've got it set up through the rectifier and through this meter and to the LED. Just going to put the camera down while I give it a crank or two. Get a pen, where's there we go. So it's about 1.5 RPMs. The meter's only reporting 3 watts, which I think is a bit off, because I think that light needs more than 3 watts to do what it's doing now. So I guess that's another way you could test it if you want to. I'm just going to turn the lights off for effect. So yeah, that's that. And I also wanted to show you that I've got it in the vise. You can see with that has to be the back end of the turbine, and this has to be the front end. If we go up like that, and that's going to be looking at the front of the turbine, there's going to be a shaft around here. Let me use a random bolt to show you where I mean. There's going to be a shaft coming out here, and this shaft, actually it'll be more like that, this shaft will have to have a gear on it which drives this turbine round. I'm already calling it a turbine, you know what I mean. So the original thought I had was to have some kind of drive belt going in here, which I knew wasn't ideal for quite a few reasons. So when I flipped it over, I was very happy to see this, and I was wondering if I will be able to actually connect some kind of gear to this. There's not enough room for it to take a complete derailleur, and that would be pointless anyway. Even if I could just get one gear on it, then that could work. Obviously the brake disc will come off unless it makes sense to keep it on there for whatever reason, which I can't see. And then what will happen with these is these will be connected into a frame, so that can't move. You might be thinking, well, can't you have it the other way around and fix this and move this? Okay, you can't. I can't really think of any way to do that when there's a wire on the back of it, because then you'll have the wire spinning around like crazy. So these will slot in the same similar way that my other project did. And really what I'm going to have to do, because I'm serious about going ahead with the project, is to butcher the wheel. I was looking in here and there's just lots of rusty bolts, so I know it sounds pretty brutal, but I'm going to have to get the grinder out and chop the spokes off, so that will be the next step. That's what it looks like without the brake disc on. A couple of bike gears, but if you look at the back, I think the only way I can connect this is if I keep some of the pedal block, which I don't think I can do, because it's really, in reality, it's all about these mounting holes, which are 44 mil apart. So something, a cog, needs to connect to this somehow and then turn that like so. This, obviously, as I keep saying, is going to be fixed in. You can't have it any other way because of the wires, unless you could knock up some slip ring malarkey. But yeah, so that's what I've got to do, is I've got to suss out how to connect a gear of some kind to that. I'm not sure, you know, normal bicycle chain will be any good. This is some chain I bought for another one of my projects. I'll just grab that, I can measure it for you. See, this stuff's quite beastie. It's 15 mil wide without the little pinion things. If I try and measure it with a pinion, it's about 16 and a bit. No, it's actually 17. So yeah, I basically really need to try, and if I want to do it, I need to try and get 2 sprockets for that. And the shaft on the top of the turbine will have the big sprocket, I think, and this one will have the small sprocket. I don't want to make it too difficult to turn. Problems I've got there is I might have to use washers, because I don't want to have to be cutting a perfectly circular hole out this size. So I'll probably use washers to stagger it a bit. And then, yeah, so I've got to try and find a sprockets online, whatever. So, as unbelievable and as wantonly destructive as it seems, I'm going to have to despoke this wheel, and I can't really be arsed with taking all the rusty bolts out. So I'm just going to hack all the spokes off. I'll put these 2 blocks of wood here to stop the bottom cables touching the floor. Yeah, where's that grinder? So, unfortunately that needed to be done, and it was a bit savage, I'll be honest. But it's for the greater good. It's what he would have wanted. To be turned into something better than he was before. Hey! Feels a fair bit lighter now. It's hard to turn. So yeah, that's the motor itself. That will be the back. This will be the front. And it will slot into something that will hold on to the two spindles. Oh, one more little bolt. Wicked. That's it for now. Bye bye bye. So these are the bearings I've settled on. I'm going to use both the same size, not the bearings, sorry, the gear cogs. I'm going to use both the same size. You see the tooth width is 7.2, I've measured that, that's fine. The bore size is 16mm, so that'll just fit over the thread completely. Number of teeth 26. So it's just going to run similarly from 26 to 26, so there's no gearing in it per se. What I need to do is make it so these are could be taken off, and I can change the cog size which is on there. You'll notice the bore size 16mm. It's all down to that. So you can't have a big bore with a very small amount of teeth for some reason, or else I would have bought another one. So anyway, I'm getting 2 of those. I've just bought 5 grams of this resin, 5 kilos, sorry, and I've got 100 grams of hardener coming, this stuff. I'm buying 2 of these with a 20mm bore size, which is that big hole there, and that's because I've got a meter of 20mm steel round bar, which I'm going to use for the shaft, for the blades to go on. So there's £5.55 each, so that's £11 for 2 of them, which is pretty good. And you'll see they've got the little Allen key bit where you can tighten up, so the shaft will go from the front to the back of the machine. 2 of these will keep it perfectly straight. You can see the little holes there. You can either bolt them down or weld them to the frame. I'll be doing some drawings at the end of this video, so you know what I mean. So that's that. I'm going to have to get some of this to make a couple of things which will join the blade holders to the shaft. So these are going to be basically, some of this is going to be welded onto the blade holder, and then when I get it I'll show you how it's going to work. These are the blade hubs that I'm going to use, although I'm hoping to make, these blades are 28 inches and I'm hoping to make a set of the 35-inch ones, so that'll be cool. What I'm going to do with this is, on here I'm going to weld a tube on here about 1 inch tall, which will fit over the shaft, and then the tube will have to have a hole in that way for which a bolt can go through the center of the shaft, and it can be all tightened up. So there's going to be one set on the front and one set on the back. So this way is facing front ways. Is that right? Or have I got that wrong? No, that's got to be front ways, isn't it? Anyway, we shall see. Yeah, that's got to be front ways. So yeah, nice. The reason I've gone with a 16mm bore is that is 15mm, that little bit that sticks up. The width of that is 15mm, so the 16mm will fit just over that, and then I'll have to drill 6 holes in the sprocket to hopefully line up with these. And that's our sprocket bolted on here. Job done. Just a bit better look at the chain I've got, which is 1/2 inch simplex, very strong. So that's what I'm going to use. The tooth width is 7.2. I know that anyway. No, I'm showing you that, but yeah, So the width of the teeth on the sprocket will fit in there, and it will fit that way. So yeah, that's cool. Just found a couple more blade hubs. That's a 5-blade one, and that's another 3-blade one, although I think that one's a bit bent. But what is bent can be straightened, so maybe, yeah, I quite like that 5-blade one. I think I might have 5 blades at the back and 3 at the front. And then theoretically, because it causes more drag with the 5, that would be the best one to have at the back, because I'm going to have the shafts kind of offset. I'll show you in a drawing. So this is a rough drawing I've done of the design, and you obviously see that's the blades at the front, that's a set of blades at the back, which that is not drawn to scale, because what's going to happen, in a similar way to the fact that the tailpipe, the tower pipe here is closer to the front end, the blades will be over here somewhere. Okay, so it will be offset. The front blade will be as close to the front of the frame, this is the frame, as possible. This here, that's going to be the front bearing which holding the shaft. This thing here is depicting the gear sprocket, which will be connected to the shaft here somewhere. I'm going to try and do it so they're interchangeable, but we'll have to see. With regards to where this joins on, that may have to be at an angle of 4 degrees, which will then cause the turbine to face up a little bit. Okay, that's just showing you the top of the tower. The motor will fit in here and is not shown in the drawing. So the chain will come from there down to here and go on the front end of the motor. So I'm going to do another drawing with that on. But that's basically so you can see how it is, because it's closer to the front. If I was to do that, it may tip up a tiny bit anyway, because you do want it poking up even from the Hugh Pigott thing, and I want, so the motor would come out of a tiny bit of an angle. I'll do another drawing and show you that. So this is a bit of a better drawing, I think, showing it. So you'll see the shaft going all the way along the top of the turbine. There's the rear bearing, just there, and there's the front bearing that holds the shaft in place. The upper drive sprocket is also on that shaft, directly above the sprocket which is on the motor here. What I've done this red to show you where the chain's going to go, and from the top there's a hole here so the chain can run through. These 2 brackets, which will be adjustable, will hold the motor perfectly in place and be bolted or secured at either end so they can't come out. The bolts attached to this will also sort out the tension. And what isn't shown here, sorry, I've just done that to show that's the end, the power wires will come out. What's not shown here is the tailpipe, which will be somewhere here. I'm not sure whether I've got to angle the tailpipe up a little bit, so I didn't show you that. So the front set of blades go on here, like so, thank you Sharpie, and the back set of blades go on here, like so. And yeah, I will do some more drawings showing you it from the front and stuff, but that's basically it. Show everything close up again. Shit, I didn't realise Fairy Liquid had mashed up your dishwasher like this.
Right.
Nice. Swindon Composite Supplies.co.uk. I think it's £27.95 for 5 kilos of resin and 100 ml of hardener, and I paid an extra £6.95 for more hardener. So if you're in the UK, or I guess they ship to Europe, and you want a good deal on some resin, give these guys a go. Sweet. Yeah. Yeah, the reason I need the resin is obviously to carry out further research and improve my blade making skills. I've got to make a set and see if they work, and then I'll be using them hopefully on this new project. With regards to the new project, this is the shaft I'm going to use, which, as I showed you, is a lovely rake that I've made, but that needs to go. So it's going to be cut off down the bottom, and also just here where it was joined, and that's going to be the shaft for the blades to fit on. Which are going to fit on like so. One set at the front and one set at the back. It's going to look sick. Invisible. I just missed my foot. This is one of the old gears of my vertical access turbine that I made. This sat at the bottom. These were attached, these arms were attached to each half of a barrel. One half barrel here and one half barrel there. No, 17. So anyway, I just thought I'd show you that, because these sprockets that I've ordered don't have this great chunky thing on the back. Okay, because then it's going to be easier to drill the bore. Now there you go, the width of the teeth is exactly 7.2. Got a load of wet and dry, so I'm going to use the sandpaper to clean this up a bit. That's a lot better now. It has to be rust free if you want to put something over the top of it. So I'm going to have the sprockets are going to need to go the top sprocket, the drive sprocket, which will be about here. The motor will sit underneath it here. So these ends have to be nice and smooth so that the 20mm whatever can go over the top of it. Yeah, so it doesn't matter if there's rust on it. If it goes rusty, it won't make any difference to the strength whatsoever. But you don't want to be messing around. The plan is I'm going to put the bearings on this and then bolt it down. And then if I want to play about with this whole assembly with the propellers on and the chain and everything, then all I'll do is unbolt it from the frame. Unbolt the pillow block bearings which go there. So yeah, it's a bit of progress. Still waiting for stuff, but peace. So yeah, I've just given it a coat of WD-40 and a rub. So looks a bit better, don't it? But that is the shaft. Sweet! Just been doing some more drawings. This is kind of an overhead diagram of the shaft. So basically you've got the front blades go there. There's a collar which connects onto the shaft, which runs from the front to the back. You've got the rear pillow block bearing and the front pillow block bearing, and between them the drive sprocket, which will be connected somehow to the spindle, and then directly underneath that will sit the motor, with the sprocket on it. The sprocket will be exactly underneath that, so there's no messing about. This is kind of a front view of how it's going to look. That's the pillow block bearing. The shaft comes through the middle there. This is the sprocket that's connected to the shaft, which is going to connect to a chain, which is going to come down. This is the motor. There's a spindle in there, and then when the blades turn, bingo, the whole of the motor will turn. The spindle will stay stationary, and the whole of the motor will turn. So this will be a metal plate whose job it is just to hold that spindle exactly in the right place, and there'll be a plate like this behind the motor as well. There's the tailpipe and obviously the tower. There was one other thing I wanted to say. Yeah, so just the front blades going on here, rear blades going on here. It's offset quite far back, so that'll be the frame will take up exactly that amount of space. And then you see I've deliberately offset the tail to the back. That is a bolt which will go all the way through the collar, which is welded onto the blade hub, and then it will have a nice strong bolt that goes straight through the middle of the collar and the shaft. So yeah, that's about it. When I get the sprockets, hopefully tomorrow I'll crack on with some more. Aye. So there's the shaft that both sets of blades are going to go onto, and I've got to drill a hole which is got to be right on this centre line. Yeah, it doesn't matter if it's exactly that far up. All it's going to be, there's going to be a collar welded onto the blade hub, which is going to slide on over here, and then it's going to have a hole in it which is going to line up with this hole. So a bolt will go from one side of the collar all the way down through the centre of the shaft, out the bottom, out the other side of the collar, and have a bolt go through so they can't slip or move at all. Just to remind you, this is what kind of blade hub I'm going to be using for starters, because that's fine with sort of fiberglass non-heavy blades. So there'll be one on the front and one on the back. It's going to be sick. So yeah, I've got to get this drilled. Bear in mind as well, these clamps are absolute doo-doo, so don't be surprised if they start flying off. But syringe with 2-stroke motor oil is what it'll have to be. I don't have any specialist oil. I was always told to drill metal at slow speed possible, which is what I do. And this is a pretty old drill bit, so so far so good. That weren't too bad, folks. That was not too bad at all. My wire brush needs an upgrade. Yeah, you can see the hole there. So that goes all the way through, and then I'll put one on the other end. So when you look at the front of the turbine, it'll kind of look like that. But the front set of blades will obviously be 1 metre up, and that will be 1 metre up. That's what you'll see from the front. That's what I mean about staggering them. I know most people will realise that, but I thought I'd show you now. That looks quite cool like that, doesn't it? Yeah, it looks pretty cool. So that's all good. Just going to take it out and do the other one now. The hole doesn't have to be offset, but the hole that goes on the hub will have to be offset. You'll see what I mean in a bit. What I've had to do to mark it up is I've got this 20mm steel block, so it's the same size as that. So all I've done is I've set the calipers for 30mm. I can't really do this, and like that sort of thing. So that should give me in the middle. Right, should be good. I have put it at an offset of approximately 60 degrees to the other one, but we can deal with that later when we're designing the hub collars. Because it'll all be matched up when I make the collar. Again, when I'm drilling, it's all about taking it nice and easy, saving the drill bit. You don't have to thrash through it. Keep using a bit of this dirt cheap oil. You don't have to use special stuff. This is just 2-stroke oil. Look at that. So that's one end. See, a 5mm hole goes all the way through. And the other end. So yeah, that's not bad, even though the parts haven't turned up. That's one of the jobs I would have had to do. The gear hub is going to be mounted about here, and I have to decide a way of mounting the gear hub. I may well use a collar, but anyway, I'm thinking of that while I'm waiting for the bearings to turn up. So that's got the shaft sorted, and yeah, that's a bit of progress. Just gave the ends a bit of a clean up, and that's what they both look like. Peace.